Hello, I'm Vitos from Vitos Academy, and today I will make some live coding solving a problem from the Discover Riga 2019 Moscow workshops called bus stops. Problem is concerning output of the maximum number of stops a person can reach from a starting stop by taking exactly one bus, and I will solve it using C# and Visual Studio and my second monitor. Okay, so let's start. Pretty much what I usually do is the following. I try to read first the input without even reading the description, then read the output, and then reading the description, and then trying to make sense of all of it. So let's try it. I don't say this is the best way, but this is pretty much my way. So the input is the first line of input contains three integers. So starting stop, number of buses, and number of stops. So this is starting stop 1, number of buses 3, and we have 5 stops. Okay, so as you see, like we have also 3 lines, so it means 3 number of buses. So starting stop is always the first one here. Then 5 buses, 1, 2, 3, 4, 5, and 3 buses and 5 stops. Okay, 1, 2, 3, 4, 5. So these are the stops. So the next B lines contain the bus routes, each written as a string of characters, where having the ith character as 1 denotes that this bus route has a stop on I, and 0 denotes that it does not. Yeah, makes sense pretty much. This means that this is the first route, first stop, the bus doesn't stop, the bus stops here and here, then the bus doesn't stop on these two. Yeah, makes perfect sense. So let's see the output. Output is the maximum number of other stops Barbara can reach from the starting stop by taking exactly one bus. Okay, so let's try to analyze. Okay, so first is the starting stop here, and we have three other stops that Barbara can reach from the starting stop by taking exactly one bus. Yes, that's true. So pretty much Barbara has here the first one, and let's try to calculate. Let's actually try to read now. Now is the time to read what is here before going into this one here and trying to make everything up. So core part of this decision where to live in a city like Bitesburg is the availability of transport links to interesting places. Definitely. This is particularly interesting to Barbara, who enlivens her stressful life as an organizer of programming camps by making frequent sightseeing travels around town in a yellow-blue bus. Okay, so pretty much what we understood from these two sentences is, yeah, just, I don't want to say nothing, but we can completely ignore it, yeah. So Barbara's ideas of a good time is a visit to a spot that takes exactly one bus journey to get to it. Could be. That's okay. She is considering moving her house to be near one specific spot along her favorite bus route, and how many other scenting spots can she reach from there, assuming that on a given trip she can choose a new bus each time. Yeah, okay, so pretty much it starts somehow making sense now, I guess. So the idea is we should simply output the maximum number of other stops that Barbara can reach from the starting stop by taking exactly one bus. Okay, so now it's probably time, I don't know, to put up an Excel and try to vision it in Excel. Otherwise, write it on a paper. But as far as I have a paper, but I cannot show it, I would show it on Excel. So I opened Excel and let's see. Okay, so yellow would be the stop on which Barbara lives, and we will put 0 here, 1, 1, 1, 0, 0. Okay, so as far as Barbara lives here, for this route we would completely be on a 0, the way I see it. Then we'll see 0, 1, 0, 1. I mean, the 0 here means that this bus stop doesn't stop, so This is how it is. Here, Barbara can reach the 4th and the 5th stop, so which is pretty much okay. And here, Barbara can reach the 4th, the 5th, and the 3rd stop. So pretty much the sum is 3. I mean, here 1, here 1, and here 1 equals 3. It's pretty interesting using Excel for solving programming challenges, but it's okay. And for the second one, it's 2, 2, 3. The answer is 0 automatically because the buses do not stop on the stop where Barbara lives. So let's try to code it, pretty much. If you took a good look at what is the solution, once you can come up with a good solution, I mean, it's really quite okay. We simply make some kind of an array, and we fill this array with the information every time from the lines here. So pretty much we make an array with 5 positions, like this. Ta-da. Or, I don't know. Ta-da. And after the first line here, we leave the array empty. After the second line, we say, okay, we're going to fill it, but we're going to fill it with these 2 positions. And after the third line, we're going to fill it with this position because this is the unique one. And we're going to simply count the number of ones in the array and give it as an answer. I mean, this is quite straightforward after we realize what is the idea of the problem. So let's code it in C#. So in C#, in Visual Studio, we go File, New, Project, .NET Framework console application is our thing, and we call it Barbara bus, or simply bus stops. Yeah. Create, and okay, now we start deleting a few useless stuff like the namespace. Control A, tab in order to make it a bit nicer. Then rename the starting class to startup. This is how I do it usually. You also rename it here. And let's start reading our input first. So our input would be written to a list. It would be list of int input, and it would be, I mean, I have a specific function or method that actually would read line and parse to list. Okay, great. If we press now Control and dot, it would tell me, hey, I can generate a method for you. And thanks. Actually, it's rather good, rather useful. Okay, private list of int. Yeah, it's exactly this one, but it's not. It won't be not implemented. It will be return console readline, and then split, then select, then parse, of course, the selected thing inside, and then everything should go to a list. Great. So our input is now a list. Our first 3 numbers, this one, 1, 3, and 5, could be written to a list. If we desire to do so, I can demonstrate. We can press F5. You can wait for the party to compile. I call it party. So 1, 3, 5, enter. And we see that we have input here. And in the input we have 1, 3, and 5, which is pretty much what we wanted to do. So let's continue. Okay, so the first thing was our starting stop, as far as I remember. Barbara's starting stop was the first one. 3 integers, Barbara's starting stop. 1 is the first possible starting stop, so this is good to know, because in the list the first index is 0, 1, so the second one is number of buses, and the third one is number of stops. Okay, so let's take the data from the list and parse it to some understandable variables. So starting stop would be input with 0th index, and actually we would remove the first one. So if the starting stop is the first stop, in our case it would be the 0th, in order to make things better. So the second one is number of buses. Number of buses, it would be input 2, or in our case input with index 1, and the third one would be number of stops, which would be input with index 2. That's pretty much so far so good. And let's think, what should we do now? So now we need two lists. The first one will be list of strings actually, and we would write our roots there. So new list of strings, and the second list would be list of int, would be things to see. So new list of int. So a bit more about these two things. So the roots, we are going to write these things here. So 0 1 1 0 0, this would be one root. 1 0 0 1 1, this would be a second root. 1 0 1 1 1, this would be the third one. So instead of making a list of lists, we make a list of strings, and this is pretty much it. So this would be about the roots. And about the things to see. The things to see, I'll go back to our Excel thing. This is our things to see list. So pretty much we would be adding here the things that are possible to be seen from Barbara. And yeah, this is going to be also our max stops pretty much. So what else do we need? Of course we need a integer max stops. Or actually, we can also, with the integer max stops, we can use the things to see count, but we'll stay with integer max stops so far. So let's start reading this stuff. So for e equals 0 to e number of stops, things to see, add 0. There are plenty of ways to write this one, but it's pretty much okay to use this one as well. So for things for e equals 0 to number of buses, here we would say string bus route equals console readline, and then routes add bus route. Okay, we could have done this as list of lists with integers. It would have been probably a bit faster, but it would work. So let's pretty much stop it here and try to see how our input is working. So what I would do is I would simulate our input quickly here from the original one. Okay, this was it, and I would put a stop sign exactly here. So pressing F5, waiting a bit for the party to compile, then going here, edit, paste, enter, and let's see, what do we have here? Things to see. We have 5 things to see with zeros, perfect. And what about the roots? These are our roots. Yeah, exactly the way we wanted it to be. So let's continue programming. I'll continue. Remove the stop. And start with the for each. Okay. For each string, for every root in our roots, actually, try to add stuff in the things to see counter. Okay, this is how we're gonna do it. So if root starting stop equals 1, Okay, so this is the only condition on which we are going to consider this route as a viable route, if the buses stop on the stop of Barbara. So if this is the case, then for every route with number of stops, for e to 0 through the number of stops, pretty much if route e is 1, and things to see in our array I is already not 1, then things to see on I write 1. That's pretty much okay, decent, and increase the max stops with 1. It's pretty much okay. What we are doing actually, we start looping, and if we start checking whether we have 1 on that specific eth element of the array, of the string, and in case that we already didn't write anything to this stop, we write it and we increase the number of stops. This would be interesting to see also, like how it works. F5, go here, edit, paste, and now with F11, let's okay, so the first route that we're examining is this one. Of course, it's not with the starting stop 1, so we go automatically to the second one, which is 0, which is actually now 1, 0, 0, 11. So starting stop is 1, so we start taking care of each one, and we see, okay, if this one is 1 and things to see, the array things to see is here. I'll simply write it here, and then here. We can start thinking, okay, in this case we entered because our I was 0, then it is with 1. So you can probably see here string root. I'll do it this well, like here. And it increases the maximum stops, okay. So the second thing, no. The third thing also won't be, but the fourth for sure would go. Yes. Here we're expecting the 1, and the fifth one as well. Yes, great. So maximum stops are 3, great. And now the new one. Okay, we'll have here 1 as well. I'm just waiting for this one, great, and that's it. Max stops are now 4. That's pretty decent. Pretty decent max stops 4 of the case, but if we go back to our description, we would see something interesting here, that the answer is 3. So the reason why the answer is 3 is because we want to output the maximum number of other stops Barbara can reach from the starting stop by taking exactly 1 bus. It's okay. I mean, 4 was considering her stop as well. Her stop without, I mean, all the stops without her stop is obviously 3. What should we write here? We should write it a bit clever. We shouldn't simply write whatever is -1, because if the result is 0, then it would be negative. Let's say that if max stops is bigger than 0, then max stops is diminished with 1. And finally, write max stops. Great. Let's try our code. Now, how is it working? Control F5. and I'm trying it with the test. The test says it's okay, 3, yeah, great. So let's try it with 115 and just the first line, 115 and the first one. The first line should give us 0 because it doesn't stop on bar reverse stop. So let's see, 0. That's pretty much great. So what should we do now? Let's go and upload our solution to the Discover Riga competition. So we go to the website. It is Riga 2019 workshops IT edu, and here we'll go into upsolving because we are not solving real time, we are solving after time, so to say. So login, my login, wait a bit, see how it will look, and here we go to submit and select a problem. Select a problem, bus stop, great. Choose file and navigate to the file. I always, before selecting the startup CS, I always take a look at edit, whether I'm submitting the correct one. It is the correct one. So press on the X, double click, and let's click on send. Well, running, compiling is good. Let's wait a bit. Compiling error. Yeah. That's rather unpleasant. View report. Okay, this is something that should never be done. So the problem is that I'm using system threading, and system threading is not allowed. But the good thing is that I can go here and you can see that I'm not using actually system threading, so it would be really easy to simply delete it and submit once again. So let's go here, problem is selected, so choose file, and now okay, click again on the startup, take a look, okay, everything's perfect. So double click, send, compiling, let's see. Okay, so that's great, our code works, and thank you for watching me with the analysis of bus stops problem from the Discover Riga 2019 workshop organized by Moscow Workshops for the 100 years of the University of Latvia. Yep, so pretty much that's all, folks. Once again, thank you for watching and enjoy your day. Bye bye.